हेलो एवरीवन। तो आज के इस लेक्चर में हम बार्क के BARC के प्रीवियस ईयर जो क्वेश्चन है वो सोल्व करेंगे। और मैं आपको बता दूं कि ये जो क्वेश्चन है वो प्योरली मेमोरी बेस्ड है। ओके, जिसने पहले बार्क का एग्जाम दिया हो और उसने ये याद रखा हो कि ये क्वेश्चन पूछे गए थे, इस आधार पे ये क्वेश्चन हो गया, क्योंकि बार्क जो है वो अपना ऑफिशियल पेपर रिलीज नहीं करता। सो बाय द वे दिस विल हेल्प यू इन योर प्रिपरेशन। सो देखते हैं हम थोड़े 5 क्वेश्चन सोल्व करेंगे इस लेक्चर के अंदर। तो पहला क्वेश्चन आपको दिया है यहाँ पे कि फॉर द सोडियम एटम न्यूक्लियर स्पिन इज हाफ। तो पहले आप न्यूक्लियर स्पिन आपको दे रखा है इधर, nuclear spin. Here nuclear spin is half, and if the total angular momentum of the orbital electron is 3/2, तो आपको दूसरा क्या दे रखा है यार, total angular momentum, it is 3/2. Then how many hyperfine line will be there? और आपको hyperfine line के जो है नंबर पूछे है कि कितनी hyperfine line इसमें मिलेगी। तो क्या करना है हमें इस क्वेश्चन के अंदर, तो देखते हैं। यहाँ हमें फर्स्ट ऑफ ऑल तो न्यूक्लियर स्पिन दे रखा है। सो न्यूक्लियर स्पिन को हम डिनोट करते हैं I से, और वो दे रखा है हमें 1/2। एंड टोटल एंगुलर मोमेंटम दे रखा है वो है 3/2। सो टोटल एंगुलर मोमेंटम को हम डिनोट करते हैं J से, और वो है हमारा 3/2। सो व्हाट इज नंबर ऑफ हाइपरफाइन स्ट्रक्चर और हाइपरफाइन लाइन? तो नंबर ऑफ हाइपरफाइन लाइन इज गिवन एज नंबर of hyperfine lines is given as mod I minus j to mod I plus j. So we substitute our value here, I and j. So I is given as 1/2 and j is given as minus 3/2. So it will be 1/2 minus 3/2 to 1/2 to plus 3/2. So 1/2 minus 3/2 you will get minus 2/2 when it will be 1 to 1/2 3/2 it will be 4/2 and 2. Okay, so the number of hyperfine line are 1 to 2. So we have to choose maximum line number of hyperfine line. So our option will be 2 will be our correct option. Okay, this is our first question. Then in second question we are given that what is the ratio of intensity between sodium D1 and D2 lines. So this question is also asked in GATE and CSIR net also. So let us solve this question. So first of all we know the sodium D1 line and D2 line. So there are 3 states in one, that is 2p 3/2, then 2p 1/2, and then 2s 1/2 in sodium. Okay, so in D1 line there are 4 D1 line. When transition happens from 2p 1/2 to 2s 1/2. So when transition happens from 2s 1/2 to 2p 1/2 to 2s 1/2, then it will be D1 line, and there are 4 D1 lines in sodium. And when transition occurs from 2p 3/2 to 2s 1/2, then it will be D2 lines, and there are 6 D2 lines in sodium, 2 3 4 5 and 6. Okay, so this is D1 line, and number of D1 lines are 4. So I can say here for D1 line, and these are 6 D2 lines. Okay, so our question is the ratio of energy of D1 and D2 line. So the energy is proportional to 2J plus 1. Okay, so here in D1 line our J is 1 by 2. I hope you know this relation. Okay, I also explain. Just see here, this is 2p half. So we write in atomic and molecular spectroscopy as L, here J, and this is multiplicity 2s plus 1. And this L, if this L is 0, then it is our S state. And if L is equals to 1, then it is T state. This is orbital angular momentum. And if L is equals to 2, this is our D state. Okay, so here J, so the J here is 1 by 2. So you can see in D1 line J is 1 by 2, and in D2 line J is 3 by 2. Okay, so I write here for D1 line J is 1 by 2. For D1 line J is 1 by 2, and for D2 line J is 3 by 2. Okay, so energy ratio of D1 and D2 will be from this relation is proportional to 2J plus 1. We can say that energy of D1 line upon energy of D2 line will be 2J, here J for D1 plus 1 upon 2J, is J is for D2 plus 1, and J for D1 is 1 by 2. So it will be 2 half plus 1, and J for D2 is 3 by 2. So 2, 3 by 2 plus 1. This 2 and this 2 will be cancelled. So we get 1 plus 1 upon this 2 and this 2 will be cancelled. So is 3 plus 4, 3 plus 1. 1 plus 1 is 2, and 3 plus 1 is 4, and 2 2s are 4. So our answer is 1 by 2. So the ratio will be 1:2. So our correct option will be B. J is 1 by 2. Okay, so this is our second question. Now move to the next question. Our third question is from solid state physics. In this question we are asked that we are given that critical temperature of ferromagnetic material. So first of all we are given ferromagnetic material is 1000 Kelvin. So critical temperature is 1000 Kelvin. That means we are given Tc, and Tc here is given as Tc is 1000 Kelvin. Tc is 1000 Kelvin. Then if susceptibility is chi1 and chi2 at 1200 Kelvin and 400 Kelvin. So we are given two temperature here. One is 1200 Kelvin and another is 400 Kelvin. And at 1200 Kelvin susceptibility is chi1 and 400 Kelvin is chi2. Then we are asked to solve this question and given the relation between chi1 and chi2. So it is very easy questions. You just have to remember the formula for ferromagnetic material, that is our critical temperature formula, and susceptibility. So susceptibility is given as chi is equals to theta divided by T minus Tc, where Tc is Curie temperature, or you can say critical temperature. So from this relation I can write that chi 1 upon chi 2, chi 1 upon chi 2 is equals to T2 minus Tc upon T1 minus Tc. So here we are given T2 as 400 Kelvin and critical temperature is 1000 Kelvin upon T1 is 1200 Kelvin and Tc is 1000 Kelvin. So it will be 400 upon 200. So the ratio will be 2. So chi 1 divided by chi 2 is equals to 2. So our correct option will be chi 1 upon chi 2. Okay, A. Okay. This is chi 1 upon chi 2 is equals to 2 also. Now move to the next question. Question number 4. This is a very important question. We have to remember formula here also. This question is of classical mechanics. Here we are given that if potential v of x is equals to k x raised to 4, then time period will be depend on energy s. So remember this formula which I am going to write. This is very important in classical mechanics. That is if potential is proportional to x to the power n, then time period will proportional to energy to power 2 minus n upon 2n. Remember this formula for time period and energy. Okay, so here we are given that time period is proportional to x to the power 4. So time period is x to the power 4. So our n is 4. So substitute n is equals to 4 here. So we are given n is equals to 4. So I substitute n is equals to 4. So t is proportional to e raised to 2 minus 4 divided by 2 into 4. So time period will be proportional to e raised to 2 minus 4 means minus 2 upon 2 into 4. Then 2 will cancel. 2 will cancel. So t will be proportional to e to the power minus 1 by 4. So main thing in this question is this formula. Please remember this. This is very important. So the correct option will be C. And then last question of this video, that is what is the value of complex integral. Okay, and you are given here f of z is 1 upon z minus 1, z minus 2, z minus 3. So this question is from mathematical physics, and you have to calculate the integral. So here we are given f of z is equals to 1 upon z minus 1, z minus 2 and z minus 3. So the formula of integration is given as summation of all residue into 2 pi I. Okay, so formula of such type integration is given as 2 pi I into summation of all residues. So we have to calculate here residues. So the formula of residue is residue is equals to limit z tends to z0 into z minus z0 f of z, and here limit z tends to, now we have three singularities here. First is at z is equals to 1, second is at z is equals to 2, and third is z is equals to 3. So we have to calculate residue at 3 point. One for z is equals to 1, second is for z0 is 2, and third for z0 is equals to 3. So first I calculate it for z0 tends to 1. So I will get like this: z minus 1, z minus 2, and z minus 3. So z minus 1 will be cancelled out, and if I put this limit here, then I will get 1 upon 1. Substitute this limit here, so 1 minus 2 and 1 minus 3. So it will be 1 upon minus 1 and minus 2. So it will be 1 by 2. So my first residue at r is equals to 1 is 1 by 2. So r1 is 1 by 2. Similarly, calculate the residue at z is equals to 2. So r2 is equals to limit z tends to z0, I put as 2, z minus z0, so z minus 2 into 1 upon z minus 1, z minus 2, and z minus 3. So this time z minus 2 will be cancelled, and you left with z minus 1, z minus 3, and your limit goes to 2. So substitute z is equals to 2 here. So we will get here 2 minus 1 and here 2 minus 3. So it will be 1 upon 2 minus 1 is 1, 2 minus 3 is minus 1. So our second residue is minus 1. So r2 is minus 1. Now residue at z is equals to 3. So our formula is limit z tends to z0, that is 3 here. So z minus 3 into 1 upon z minus 1, z minus 2, z minus 3. So this time z minus 3 will cancel, and put z is equals to 3 here. So it will be 3 minus 1, so 2, and 3 minus 2 is 1. So it will be 1 by 2. So our third residue is r3 is equals to 1 by 2. So now substitute this value in formula, that was integration I is equals to 2 pi I into summation of all residue. So it will be 2 pi I. We have three residues, r1, r2, and r3. So it will be r1 plus r2 plus r3. So 2 pi I. Here r1 is 1 by 2, r2 is minus 1, and r3 is 1 by 2. We got. So here 1 by 2, 1, and minus 1 is 0. So our answer is I is equals to 0. So our correct option will be maybe D. Okay, so our correct option is D. So thank you for watching my video. Thank you.